Welcome back to Sec 1 Geography. Today we are starting Unit 2, Natural Resources and Sustainability. This is a topic where the marks are within reach. You do not need to read a climate graph or identify landforms. You need precise definitions, a clear understanding of why resources come under pressure, and a method for evaluating management strategies. By the end of this video, you will be ready to answer every question the WA and final exam can throw at you on this topic. Let's get into it. Before we go to the definitions, I want you to think about something concrete. Every time you charge your phone, that electricity almost certainly came from a power station burning coal or natural gas. Every plastic bottle you have ever held was made from crude oil. Every steel beam and every building you have walked through came from iron ore extracted from the ground. Here is the part that matters. These materials took hundreds of millions of years to form inside the Earth, and we are using them in a matter of decades. So, what happens when they run out, and what can we actually do about it? Those two questions are exactly what this topic is about. Here is what we are covering today. Look at the roadmap on screen. Chapter 1 is about what natural resources are, the exact definition, and how to classify any resource as renewable or non-renewable. Chapter 2 looks at why resources come under pressure and introduces the 5-stage depletion cycle. Chapter 3 is about sustainability, the Brundtland definition, and what sustainable development means in practice. Chapter 4 covers the 3 management approaches: conservation, efficiency, and substitution, with examples from Singapore and around the world. And by the end of Chapter 4, you will know exactly how to structure the 6-mark evaluate question on the final exam. That question is worth 6 marks on its own. It is the single highest value question in this unit. Before we look at any content, let me tell you the 3 mistakes I see most often on natural resources questions. Each one costs marks every time it appears. Look at the screen. Mistake 1, giving an example instead of a definition. Water is a natural resource. That is an example. It is not a definition. A definition tells you what a thing is, not what a thing is. A-N-E example of. The mark goes to the definition, not the example. Mistake 2, writing about management strategies when the question asks why a resource is under pressure. These are 2 completely different questions. If the examiner asks why a resource is under pressure, they want causes: demand growth, finite supply, environmental damage, not solutions. Mistake 3, only one reason for a 3-mark question. 3 marks means 3 distinct reasons. Write one beautifully and stop. You lose 2 marks. Always write 3. We are going to fix all 3 in this video. So why does this matter? Look at the exam questions on screen. WA question 1 is 1 mark. Define natural resource. WA question 2 is 3 marks. Compare renewable and non-renewable resources. WA question 3 is 3 marks with reference to a named resource. Explain why it is under pressure. And then the final exam has the 6-mark evaluate question. Evaluate how effective a management strategy is in ensuring the sustainable use of natural resources. That is 13 marks in total from this one topic. This video covers every single one of those questions: the definition, the comparison, the pressure explanation, and the evaluate structure. Let's start with Chapter 1. Chapter 1. What are natural resources? This chapter is all about the foundation, the definition, and the classification system. I know definitions can feel straightforward, but they are exactly where geography marks are won or lost. Pay close attention to the 2-part rule coming up in the next slide. Here is the definition. Read it with me as it appears on screen. A natural resource is any material or substance found in nature that humans use to meet their needs. Now, notice 2 parts to this definition. Part 1, found in nature, meaning it exists in the natural environment, not manufactured or made by humans. Part 2, used by humans to meet their needs, for food, energy, shelter, or industry. You need both parts to score the mark. Water is a natural resource is an example. Any material found in nature that humans use to meet their needs. That is the definition. The examiner wants the definition. Look at the examples at the bottom of the screen. Water, timber, coal, fish, sunlight, iron ore, all found in nature, all used by humans, all natural resources. Now let's look at the two types. This comparison is tested directly in WA question 2. Look at the table on screen. On the left, renewable resources. On the right, non-renewable resources. Renewable resources can be replenished naturally within a human timescale. Solar energy renews every single day. The sun does not run out. Wind energy is continuously replenished by the atmosphere. Water cycles through evaporation and rainfall. Timber grows back if trees are replanted. Fish populations reproduce if stocks are maintained. Non-renewable resources cannot be replenished within a human timescale. Coal, oil, and natural gas took hundreds of millions of years to form from ancient organic matter. Iron ore and copper are extracted from finite underground deposits. Once they are used, they are gone. No geological process will replace them within a human lifetime. Look at the Singapore examples at the bottom. Water is renewable here. Singapore recycles used water through NEWater and collects rainwater in reservoirs. Oil is non-renewable. Singapore has absolutely no oil reserves. Every drop of oil used in Singapore is imported. So why do natural resources matter? Look at the 4 categories on screen. Humans depend on natural resources for food: fish, freshwater, crops, and soil. We depend on them for energy: coal, oil, solar power, and wind. We depend on them for shelter: timber, stone, steel, and concrete. And we depend on them for industry: the minerals, metals, oil, and gas that fuel the global economy. Think about your day so far. You ate food grown with water and soil. You charged a device using electricity. You sat in a building made of steel and concrete. You traveled in a vehicle running on fuel. Every single one of those things required a natural resource. Without natural resources, daily life as we know it is not possible. That is why this is not just an exam topic. It is one of the most pressing challenges facing the world right now. Now, here is the most important insight in this chapter. I want you to carry this with you through the rest of the video. Renewable does not mean unlimited. Look at the 3 examples on screen. Fish are renewable. They reproduce. But if a fishing fleet catches fish twice as fast as the population can reproduce, the stock collapses. A collapsed fishery cannot recover on its own. The Atlantic cod fishery in Canada did exactly this, overfished to collapse in 1992, and it has never fully recovered more than 30 years later. Forests are renewable. Trees grow back. But if we clear forests faster than they can regenerate, the land degrades permanently. Deforestation is not just a slow process, it can make a renewable system irreversible. Water is renewable, it cycles through evaporation and rainfall. But in some regions, groundwater is being extracted faster than rainfall can replenish it. The aquifer depletes. A renewable resource becomes functionally scarce. Look at the definition on screen. Overexploitation means using a resource at a rate faster than it can naturally recover or be replaced. A renewable resource that is overexploited behaves just like a non-renewable one. Keep this in mind. It comes up directly in the worksheet and the WA. Excellent work so far. Let's check your understanding before moving on. Look at the 5 resources on screen. I want you to classify each one as renewable or non-renewable and give one reason for your answer. Pause the video now. Work through all 5. When you're ready, unpause and I will show you the answers. Welcome back. Let's go through the answers together. Look at the answer table on screen. Coal, non-renewable. It is a fossil fuel that formed over hundreds of millions of years and cannot be replaced once used. Wind energy, renewable. It is continuously replenished by the atmosphere. The wind will not stop. Natural gas, non-renewable. Also a fossil fuel. Finite supply. Once burned, it is gone. Timber from a managed forest, renewable. Trees grow back. The key phrase is managed forest. That means replanting keeps pace with harvesting. Without management, it could easily tip into overexploitation. Crude oil, non-renewable. Fossil fuel, finite reserves. The same answer as coal and natural gas. Now look at the key reminder at the bottom of the screen. Renewable means can be replenished, not will be. Managed sustainably is the condition that keeps a renewable resource renewable. Remove the management and you remove the guarantee. Well done. Let's move on to Chapter 2. Chapter 2. Resources under pressure. Now that you can classify resources, let's look at why they come under pressure. This is the direct preparation for WA Question 3. Explain why a named resource is under pressure. You will need 3 distinct reasons. Let me build that framework for you now. Why are resources under pressure? Look at the 3 factors on screen. First, population growth. More people in the world means more demand for food, water, energy, and materials every single day. Global population passed 8 billion and continues to grow. Each additional person needs resources from the day they are born. Second, economic development. As countries industrialize, building factories, expanding infrastructure, growing cities, developing a middle class, their energy and material consumption rises dramatically. Countries that were once low-resource economies become major consumers as they develop. Third, urbanization. Cities use more resources per person than rural areas. Urban lifestyles typically involve more electricity, more transport, more manufactured goods, and more food that has been processed and packaged. The result? Resources are extracted faster and faster. Non-renewable resources deplete toward exhaustion. Renewable resources face overexploitation. Notice that on screen, population growth, economic development, and urbanization are 3 separate, distinct reasons. That is exactly the structure you need for WA Question 3. Let's define overexploitation precisely. Look at the definition on screen, using a resource at a rate faster than it can naturally recover or replace itself. Now the consequences. There are 2 main ones. Consequence 1, resource depletion. As stocks decline, remaining deposits become harder and more expensive to reach. Think of oil. The easy, cheap deposits close to the surface were extracted first. What is left requires more technology, more cost, and more energy to extract. Supply falls while demand continues to rise. Consequence 2, ecosystem damage. When resources are over-extracted, the surrounding environment suffers alongside the resource itself. Deforestation causes soil erosion. Overfishing causes species. Population crashes across the food web. Oil extraction causes pollution. Ecosystem damage is often longer lasting than the depletion itself. Look at the case study on screen, the Atlantic cod fishery. For decades, trawlers overfished cod in the North Atlantic. By 1992, the Canadian government declared the stock had collapsed and imposed a fishing ban. Over 30 years later, the fishery has never fully recovered. One renewable resource permanently changed by overexploitation. Now look at the 5-stage depletion cycle on screen. This is a framework for understanding how any resource, renewable or non-renewable, moves from abundance toward crisis. Stage 1 is discovery. The resource is found. Its value is recognized. Industries and economies begin to form around it. Stage 2 is exploitation. Extraction grows. Demand rises. The resource becomes essential to the economy. Think of the global oil industry built in the 20th century. Stage 3 is overuse. This is the critical turning point. Extraction starts to exceed replenishment or safe use. Short-term economic gain is prioritized over long-term sustainability. Regulation is absent or weak. Stage 4 is scarcity. The resource becomes harder and more expensive to obtain. Supply falls while demand keeps growing. Prices rise. Stage 5 is crisis. The resource is severely depleted. Industries, communities, or ecosystems that depended on it suffer severely or collapse entirely. Notice the green arrow at Stage 3. Management strategies are most effective at this point, before scarcity becomes a full crisis. Once you reach Stage 5, the options are far more limited and far more costly. This cycle applies to crude oil, fish stocks, forests, and groundwater. It is the conceptual engine behind why management matters. Chapter 3, Sustainability. We have seen the problem, resources under pressure, the depletion cycle, the risk of crisis. So, what is the guiding principle behind every management response? That is what this chapter is about. Here is the most important definition in this entire topic. You need to know this word for word. Look at the screen and read it with me. Meeting the needs of the present without compromising the ability of future generations to meet their own needs. Brundtland Commission, 1987. Write this down if you have not already. This definition appears directly in the WA, defines sustainability, and it forms the evaluative framework for the 6-mark final exam question. Notice the 2 parts. The present generation, their needs are met today. The future generation, their ability to meet their own needs is preserved. Sustainability is not about stopping resource use. It is about managing resource use so that it can continue indefinitely, without destroying the capacity of people who come after us to live well. Sustainability is the principle. Sustainable development is what it looks like in practice. Look at the 3 pillars on screen. Sustainable development means balancing economy, society, and environment together, not choosing one at the expense of the others. A strategy that protects the environment but destroys livelihoods is not sustainable. A strategy that grows the economy but poisons the water supply is not sustainable either. True sustainable development maintains all 3 pillars at once. Look at the Singapore example at the bottom of the screen. Singapore has no large rivers, no natural aquifers, and very limited land. Yet it maintains reliable water security for nearly 6 million people. How? NEWater recycles used water. Desalination plants convert seawater. Reservoirs collect rainwater. Water pricing discourages waste. The result, economic growth continues, communities have stable access to water, and the environment is managed carefully. That is, all 3 pillars, economy, society, and environment, working together. Let's move to Chapter 4. This is where everything comes together. Chapter 4. 3 Approaches to Sustainable Management. Everything we have covered so far, the definition of natural resources, the depletion cycle, the Brundtland principle, has been building toward this chapter. 3 management approaches, each with a definition, examples, a strength, and a limitation, and a structure for evaluating them in the 6-mark final exam question. Let's go through them one by one. Approach 1 is conservation. Look at the definition on screen. Conservation means protecting resources and ecosystems from damage or depletion by limiting use and preserving natural systems. How does it work? 3 main methods. Fishing quotas. Setting an annual limit on how much of a resource can be caught, so stocks have time to recover. Protected areas, zones where extraction is banned or restricted entirely, allowing ecosystems to function without human interference. And banning destructive practices. For example, banning bottom trawling, which damages the seabed and indiscriminately catches non-target species. Look at the 2 case study boxes at the bottom of the screen. Singapore's example, Sungei Buloh Wetland Reserve. Mangroves and wildlife protected from coastal development since 1993. It was later recognized as a Ramsar wetland of international importance, one of the world's most significant mangrove systems. The global example, Marine Protected Areas, or MPAs. Restricted fishing zones worldwide that allow fish stocks to recover inside their boundaries. The Great Barrier Reef Marine Park in Australia covers over 344,000 square kilometers of protected ocean. Now let's evaluate conservation. Look at the 2 columns on screen. The strength, conservation directly prevents further damage and depletion. It preserves ecosystems and resources for future generations. If enforced effectively, it can allow a depleted resource to recover over time. Fishing quotas have allowed some North Sea fish populations to partially stabilize after decades of overfishing. The limitation, conservation, frequently conflicts with economic needs. Fishing communities lose income when quotas are imposed. Protected areas restrict land use, affecting farming, development, and local livelihoods. And most importantly, conservation is very difficult to enforce across international borders. No single country owns the open ocean, and illegal fishing, illegal logging, and illegal mining continue despite legal protections. Remember this structure for the evaluate question. It is not enough to say conservation protects ecosystems. You need to say WHY that makes the strategy effective, and WHY the limitation reduces its effectiveness. The because is where the mark lives. Approach 2 is reduction and efficiency. Look at the definition on screen. Reduction and efficiency means using fewer resources to achieve the same result, or reducing wasteful consumption. How does it work? 3 examples on screen. LED lighting uses approximately 75% less energy than traditional incandescent bulbs to produce the same amount of light. Drip irrigation delivers water directly to plant roots and uses 30 to 50% less water than surface flooding methods. Recycling reduces the need to extract and process new raw materials. Less mining, less energy, less depletion. Singapore example, the Water Efficiency Labeling Scheme, or WLS. Appliances are rated on how efficiently they use water. Consumers who choose WLS-rated washing machines and dishwashers use less water without changing their behavior in any other way. Combined with NEWater recycling, this significantly extends Singapore's effective water supply. Global example. LED lighting replacing incandescent bulbs has been one of the largest energy efficiency gains in recent decades, applied immediately, at low cost, across the entire world. Evaluating efficiency. Look at the 2 columns on screen. The strength, efficiency extends the lifespan of existing resources without needing to find new ones. It also reduces costs. Energy-efficient appliances cost less to run, which benefits both consumers and businesses. And critically, it can be applied immediately. You do not need to build new infrastructure or discover a new resource. You just use the existing resource more carefully. The limitation, efficiency, requires behavior change, which is not guaranteed. People must adopt new habits and sometimes invest in new equipment. And there is an effect worth knowing. It is called the rebound effect. When a resource becomes cheaper to use, people often consume more of it, which partially offsets the efficiency gain. Fuel-efficient cars are a clear example. As each kilometer costs less petrol, people drive more kilometers. Overall oil consumption does not fall as much as the efficiency gain would predict. Efficiency buys time, it extends the runway, but it does not eliminate the underlying pressure on resources. Approach 3 is substitution. Look at the definition on screen. Substitution means replacing a scarce or non-renewable resource with a more abundant or renewable alternative. How does it work? 3 replacement pairs on screen. Coal power replaced by solar or wind energy. Petrol vehicles replaced by electric vehicles that run on electricity from renewable sources. Old-growth timber replaced by sustainably certified alternatives. Singapore example, solar panels are being installed on HDB rooftop car parks and community buildings across the island. Singapore has also announced plans to phase out all petrol and diesel vehicles by 2040, replacing them with electric vehicles. This shifts the transport sector away from a finite non-renewable resource toward electricity, which can be generated from renewables. Global example. Germany's Energiewende, which translates as energy transition. This is a national policy to phase out coal and nuclear power and replace the entire electricity supply with renewable energy. Renewables now supply more than 50% of Germany's electricity. This is substitution implemented at national scale, and it has been underway since 2000. Evaluating substitution. Look at the 2 columns on screen. The strength, substitution, addresses the root cause. It does not slow the depletion of a resource, it eliminates dependency on it entirely. If Singapore generates all its electricity from solar panels, it no longer needs to import oil or gas for power generation. The resource pressure is removed, not just reduced. And renewable substitutes, solar, wind, hydroelectric, can last indefinitely, which aligns directly with the Brundtland definition. The limitation, substitution, requires high upfront investment. Solar panels, electric vehicle infrastructure, battery storage systems, all of these cost significant capital. For developing nations, this is often unaffordable without international financial support. The technology for some substitutions does not yet exist. There is no clear renewable substitute for certain rare minerals used in electronics, for example. And even in wealthy nations like Germany, the transition takes decades. During that transition, the old resource continues to be used and depleted. Now look at the comparison table on screen. This is your reference for the evaluate question. Conservation targets the rate of depletion, medium-term impact, low to medium cost. Efficiency targets how much of the resource is consumed, immediate impact, low to medium cost. Substitution targets the resource itself, replaces it with a renewable alternative. Long-term impact, high initial cost. For the evaluate question, understanding this comparison matters. A strategy that combines efficiency and substitution, as country A does in the practice pause, covers immediate impact and long-term root cause removal. That is stronger than either approach alone. Now look at the 6-part structure at the bottom of the screen. For a 6-mark evaluate question, every mark maps to one step. Identify the strategies. Explain a strength with a reason. Develop or add a second strength. Explain a limitation with a reason. Develop or add a second limitation. Close with a final judgment, a clear position on whether the strategy is effective with one reason. Get ready. The practice pause is next. Here is your practice pause. Read the country. A scenario carefully on screen. Country A has large coal reserves supplying 70% of its electricity. The government plans to switch all electricity generation from coal to solar energy over 20 years. They will also improve energy efficiency in homes and businesses. Your task: evaluate how effective this strategy is in ensuring the sustainable use of natural resources in Country A. 6 marks. Use the 6-part structure from the previous slide. Aim for around 200 to 250 words. Pause the video now. Write your answer. When you are ready, unpause and I will walk through the model answer step by step. Welcome back. Let's go through the model answer together. I am going to mark each of the 6 elements as we go. Step 1. Identify the strategies. Country A uses substitution, replacing coal with solar energy. And efficiency, improving energy use in homes and businesses. Naming both strategies earns the first mark. Step 2. Strength with reason. Solar energy is renewable. Unlike coal, it will not deplete. By shifting from a finite fuel to an indefinitely available one, Country A directly reduces the long-term risk of an energy crisis. That, WHY, removing dependency on a finite resource, is what earns the mark. Step 3. Develop the strength. The efficiency measures further reduce overall energy demand. This means less coal is needed during the transition, and less solar capacity will be required once the transition is complete. It extends the lifespan of existing resources. Step 4. Limitation with reason. The 20-year transition period is very long. During this entire period, coal continues to be used and continues to deplete. The strategy does not stop the problem, it defers it slowly. Step 5. Develop the limitation. Coal mining communities face unemployment as the transition proceeds. This generates political resistance, which can slow implementation or cause the plan to stall before coal dependency is meaningfully reduced. Final, Step 6. Final, Step 5. Step 6. FIME. Overall, the strategy is moderately effective. It addresses the root cause and sets a credible long-term direction. However, its success depends on adequate funding, sustained political will, and support for affected communities. Without these, the strategy risks stalling. My 6 marks. Notice throughout I used specific names: coal, solar, Country A. I explained WHY each strength and limitation matters, and I committed to a position in the judgment, moderately effective, with a clear reason. That is the structure every time. Let's close with 5 things to take away from this video. 1. A natural resource is any material found in nature that humans use to meet their needs. Renewable means it can be replenished within a human timescale. Non-renewable means it cannot. 2. Renewable does not mean unlimited. Overexploitation of a renewable resource, overfishing, deforestation, groundwater extraction can cause permanent depletion. The renewable label describes potential, not a guarantee. 3. The resource depletion cycle goes discovery, exploitation, overuse, scarcity, crisis. Management works best at stage 3, before scarcity becomes a crisis. 4. The Brundtland definition, meeting the needs of the present without compromising the ability of future generations to meet their own needs. 1987. Learn it word for word. 5. The 3 management approaches. Conservation slows depletion, medium term, lower cost. Efficiency reduces use immediately, low cost, immediate impact. Substitution replaces the resource entirely, long term, high initial cost. Each has strengths and limitations. The 6-mark evaluate question asks you to work through all of this systematically. Here is what to do next. Complete the viewing guide and revision note in your learning pack. They reinforce everything covered today. Then attempt the WA practice, 7 marks, 15 minutes, no notes. And then take on the final exam practice. That is the 6-mark evaluate question. You now have all the tools to score well on it. If this video helped you, subscribe. The next video in this series covers water and the water cycle. See you there.